Okay, so we are going to start with the topic of recursion. Okay, topic is recursion. So it's a technique. It's basically a technique of programming that could be applied in any language. Okay, just like we learn linear search, binary search, right? Bubble sort. These are techniques or algorithms, right? That could be applied in or implemented in rather in any languages, right? Similarly, we are going to start with recursion, the idea or the concept of recursion. Okay. So, what is the literal meaning of recursion? Can you search in the phone? Recursion, the literal meaning of recursion. Look at the spelling over here and search in the phone. What is the literal meaning? What does it mean? What are you getting? Function call directly or indirectly. Is this the meaning that you are getting? The literal meaning. Okay, let me see it here. I don't know. I have never searched. I just wanted to see how it recursion meaning. ठीक है? Let's see. What is that we are getting? The repeated application of a recursive procedure or definition. We have given some definition, right? And in terms of programming language, if that is something which does something, it is represented as a function, right? That function has got some lines of code to do something, right? So the repeated application of a procedure, that is also called as procedure, right? A function is also termed as a procedure to do something, right? So the repeated application of a recursive procedure or a definition is called as recursion. That means the same function is being called or applied again and again, ठीक है, to achieve a task. Now that looks like a weird thing, right? If I have got a function, I can just call the function and I can get the output. What do we mean by applying the same function again and again to achieve that goal, right? So to understand this, let's try to, you know, remember our own previous studies, uh, like we did as a treasure hunt for linear search and binary search, right? So you must have played the games. So they are chests, right? So in the chest you will try to figure out the treasure you are looking for, right? And here that treasure is the treasure key or the search key, right? In terms of linear search and binary search I am talking about, right? So it says hide a secret treasure number, which is a key, and watch how recursive linear search walks along the array and finds it. So as of now, what we have seen is, if we talk of the linear search algorithm, which is represented in a single function, we just pass the array, we just pass the search key and the size of the array. That's it, and it iterates over each of the element, right, to figure out where that search element lies in a linear fashion, right? So there is no recursion over there. In our previous example, there is no recursion over there. That's not recursion. That's not recursion. So recursion is something which works in a way when a task to handle is seen as a too big task, right? So we start doing a tiny piece of it and then keep on asking the implementation of the same helper function to solve it. And we try to solve it in breaking the problem to such an extent that we come to a stage where it remains like a small problem and we know the answer for that small problem. Okay? Correct? So that level where we reach or we keep on breaking the bigger problem into at a level of smaller problem which for which we know the answer, that smaller problem or that stage is called as base case. That is called as base case. Okay? Correct? Now, like for example, suppose we have got a problem, not necessarily linear search, any problem. This is general idea. It is of size 5. Okay? We break it down to a smaller size of 4 problems. If this is not the base case, that means we do not know the answer for the size 4. We further break it down to a smaller size of size 3. Okay? If for size 3 also we do not know the immediate answer, we break it further to size 2, to size 1, to ultimately to one size which could be size 0. I can refer it as size 0, and that I call that for this particular size of the problem I know the answer very clearly, and this is going to be my base case. Okay? So one thing is a problem as a whole, which is a larger problem, and if that problem is divided into in a fashion such that we keep on trying to solve the same problem again and again with smaller size of the problem, and we reach to a certain size where we know the answer, then we say that that size or that stage is a base case. Okay? Now, yeah, a small problem, right? Now the way we do could be one of the ways that we learned before, like in the case of linear search and the binary search. One function is responsible for taking the whole of the array, the size of the array, and the search key, and it will look for the key linearly starting from the start to the end, right? In one function itself, in one function call itself, right? So we are not breaking the problem into a smaller problem there, right? We are not looking for any base case. Rather, we are just solving the problem in one go. Same goes for binary search algorithm where the array is divided into two halves. We go with either half, and in the same function we keep on doing it again and again, right? So that's the same function. But by the definition of the recursion, as we have seen, the literal meaning, it says the repeated application of a recursive procedure or definition. Now here the thing changes. Changes in the sense that we are not going to do in one go in the same function. Okay? Rather, we will keep on utilizing the same function again and again to reduce the size. Looks like a mysterious thing, right? Don't worry. We are going to understand it very soon. So think like a story. If I cannot solve it now, I make a smaller version of the same problem and ask myself, the smaller version must move closer to the base case. The first thing is that the base case is something which you know, right? For that base case, I know the solution. I will try to keep on moving by reducing the size of the problem unless we reach to a stage where we reach the base case to which we know the solution. ठीक है? So to apply a recursion to any problem, we must clearly know the base case, and we know that after this stage we do not need to go any further, right? ठीक है? Okay. Now let's look at this code, the recursion code for linear search, right? ठीक है? We have seen the code of linear search before. We have studied that in class. Now we will do the same thing in recursive way. And by recursive, the definition says we will apply repeatedly a recursive procedure. We will keep on applying the same procedure repeatedly until we reach a base case. That is hidden centers. Okay? Look at this code. Linear search is the name of the function. As before, we are passing an array which is already populated with the elements. Okay? We know that linear search doesn't require the array to be sorted, right? We pass the position, and this position indicates the position from, rather the index position from which we need to start searching in the array. So that means initially the position must be index position 0, correct? Because the array index starts at 0. Then the key to search, it may lie anywhere in the array. So I need to pass a search key or the treasure that needs to be searched. And n is the number of elements, that is the array size. So index will start from 0 if we go for a previous linear search algorithm, and it should end at what? N minus 1, right? Now I told you that if I want to solve this problem, not exactly the way we did before, but rather using the recursion, okay, we must in advance know the base case. Okay? So here we have defined a base case 1. Okay? So there are two base cases. Base case 1. We will know the answer for sure if I traverse the array to search the element and I go beyond the last valid index, that is n minus 1. If I reach to n, which is not a valid index, an element is not found, I know this is a base case that I can say for surety the answer that the element is not in the array. One base case, right? Correct? There could be multiple base cases also. The other base case is element found at current index position, which is referred by the POS, reference variable POS, right? If the element is at that position, we will just return the index position, right? Or position, right? That is the second base case. And in our example, these are the only two base cases. In any of the reaching to any of the base cases means we know the answer for sure. We do not need any further recursion or division of a larger problem, right? Correct? Now just look at it. Do you see any for loop to traverse the array starting at index position 0 to n minus 1 like we did in the previous implementation of the linear search algorithm? No. What we are doing is we are calling the same function linear search by passing the same array that we have received at the entry time, and instead of position I am just passing position plus 1. That means initially if the index position is 0, the index position becomes 1. So initially if the size of the array was 10, and the problem size was 10. Now the problem size is reduced to 9, right? I'm reducing the size of the problem as well. The same key I am passing again, and the same n I am passing again. Only difference is happens here is the position size is increased by 1, and thus reducing the search space by 1. You didn't get it. Hold on. This is complicated to understand. Don't worry. Okay? If you're not understanding, this is complicated to understand. The most difficult thing. In fact, recursion is not seen as a good practice in modern programming terms because of its complexity to understand it while debugging it. When you get into problem, you have to debug it, right? Where I am stuck, right? Because recursion gives a very less transparent understanding of how it is working from inside. So this is not very easy to understand, and that is why I will never try to apply recursion over a problem like of a recursion linear search, right? Our previous implementation that uses a for loop to start from index position 0 and to keep on incrementing or iterating till index position become n minus 1, either exceeds or we get the search element, and wherever we get the search element, we break out of the loop and report it, right? That was a better implementation. So you do not expect me to answer a question why I am applying recursion into this particular example. There are other examples where recursion makes sense. Here it is not the best preferred algorithm, rather we are doing it just to understand how recursion works. Soon we will also see the places where recursion is more desired as a method. Okay? Okay, from this implementation, what you see? Imagine a smaller size. Say array size is equal to 3. Array size is equal to 3. When the main method is going to call this function, what are the values it will pass? An array with 3 populated values, right? What will be the initial position? 0, of course, because the index position starts of array from index position 0. The key, let's assume it could be in those 3 elements in the array, or it could not be there in that, but there is a key, a variable that holds some value to be searched. What is going to be the size of n? 3, right? Now we come to the first stage, the first base case. We try to check for the first base case. If position is greater than n, tell me, is the answer true or false? Is position greater than n? Position is what? 0 in the first call to this method. When I call this method from the main method, right? Position is sent as 0. So is 0 greater than 3, the size of the array? No. So this statement will not run, right? Right? If condition fails, so the statement after if condition will not run. It will move further. So first base case is not met. It will come again to check for the second base case. Remember, the base cases are the stage where we know the answer. Okay? Element found at current index position. Array position is equal to key. Okay? So let's assume 3 elements, 2, 4 and 6, which are in the array. And the search key is what? 6, the last element. Okay? The array elements are 2, 4, 6. It's an array of just 3 elements. N is equal to 3. Initially position came as 0. So array position 0 contains which value? 2. Because we have only 3 values, 2, 4 and 6. At index 0, 2 is there. At index 1, 4 is there. At index 2, 6 is there. So array position 0 contains the value 2. So this value will be replaced by physical value 2 is equal to double equal to key. It is going to check against the key. Double equal to means it is going to check against. Single equal to means assignment. I am not trying to assign key to array position 0. I am trying to cross check for the equality of these two values, right? So you have to use double equal to. So what is the key value? 6. Whether 2 is equal to 6 or not? No, right? So it's false. So when it false, second base condition also turns false. So we have not reached to any of the base conditions, right? If we have reached to, in case if we would have reached to any of these base conditions, the recursion would have stopped. I mean, I'm not going to further divide the problem into smaller versions, right? Correct? So we have checked for what? For position 0, right? And neither the array is exhausted, we have not traversed to the end of the array, nor the element is available at the index position 0, the first position, right? So both base conditions are evaluated to be false. Okay, they are not found. So we will break the problem recursively, and by recursive, let me remind you again, the definition of recursion was repeated application of a recursive procedure. That means the same procedure or the same function, I will say here, the same function linear search is applied again. Okay? If there would have been written 0 in this line number 9, the program would have ended. Written -1, written 2, anything, program would have come back to the main function from where it is being called. It's not doing that. It's returning with another call. And this time it is again passing the same array. Only the position is slightly changed to one element. Position becomes 0 plus 1, which becomes 1. So we have just to find out the base case, we have already checked the index position 0. Now we move the index position to 1, right? Key is same, it contains 6. N is same, it contains 3, right? And we send the call back to the same function. That means I am using the same person. If I want to assign some task to a person, I ask him a larger task. He is confused. He comes to me. Sir, I'm not able to find the answer. I will say, okay, let me reduce the size of the problem. Now go back and try this. He comes again, sir, still I am not able to find the answer. I will reduce the size still. And I will say some condition where you will find the answer. These are the base conditions. He will keep going and trying to solve, and he will keep coming to me back. And I will be handing the same problem to him again, the same person, until he is able to solve the problem. Okay? And return back to me. Sir, I have got the problem for this smaller solution. So I will use that smaller solution to solve a bigger solution, if that is the case. Okay? So I am calling back the same linear function again. And if there is no base case, then what will happen? That will enter into infinite loop, right? Yeah, it will enter into infinite loop, right? So we are aware that we must already be informed about the base condition, so that we are pretty much sure that at this certain point it is not going to call further the same function again, and the recursion will end. Otherwise we will enter into infinite loop. Okay? Any number of base cases, depending, it makes sense. Like here, the two base cases make sense. One is either we have traversed to the end of the array, we have passed the last element, and we have not found the element. So we will say, we will just return -1. Index position -1 means we have not found it. It's beyond the limits of the array, right? The index is beyond the limits of the array. Or we have found, we will return the position. Position is the index. Okay? So these two are the base cases. Okay? And there could be any number of base cases until they make the sense. Okay? Okay? Now I am calling the same function again. It will come again with the same array values. But instead of checking the 0th position, I will start checking with the 0 plus 1 position, because here we have sent a new value position plus 1, which is 0 plus 1 is equal to 1. The key remains same, the size remains same, size of the array, right? We come back again for the base case one. If position size is greater than n, what is the position size now? 1. What is the size of n? 3. Is 1 greater than n? No. Minus 1 will not be returned. We will proceed further. Base case 1 is not applied here, not found rather. If array position of, what is position 1? ARR 1. What is the ARR 1 translated to? The element 4. 2, 4, 6. Remember, these are the elements. So 4 is the second element at index position 1. 4 double equals to key. What was the key? 6 I said. So 4 is equal to 6. This is the question. Answer is no. 4 is not equal to 6. So the condition fails. I am not going to return the position again. So neither base case 1 nor base case 2 will be applied over here. Okay? Just keep on imagining in your mind. Okay? Then we will come back again. Still I need to break the problem into a smaller version, and as per the definition, calling the same function again. Okay? Now I will call linear search with the same array, and this time position becomes what? Tell me. Position become 2, because earlier position was 1. 1 plus 1 is 2. Search key is still 6. N is 3. The control will come back to the same function again. Enter the same function. It will check for the base case. If position 2 is greater than 3, false. It will not return minus 1. It will come further. If array at position 2, array element at position 2 is equal to the key, I told you at position 2 the array element is indeed 6. And this is the key that we are searching. Right? So what will happen? It is found and it will return position. Okay? Now it will come back to the place where I have called the linear search with position is equal to 2. Right? Right? And with what value? Position is equal to 2. Position is equal to 2. I am returning position, not the value. Position, right? The index position. It will come back to position equal to 2. And this function was previously called by itself with position 1. The same value 2 is written back again, till it reaches to the final stage where we have started calling it. And then it will search to its caller, which is the main method, with the position value 2. ठीक है? समझ में आ रही है या नहीं आ रही बात? लगता नहीं आ रही है. अच्छा, I have a way to show it, but I cannot show it in C, because there are certain tools which I can use to show it, but I cannot show it in C. क्या बात है बेटा? अभी टाइम लगेगा. 11 बजे नहीं, 11 शुरू हुई है ना, 12:30 1 तक. ठीक है? तो आपको मैं यही एल्गोरिथम दिखा सकता हूँ जिससे आप ट्रांसपेरेंटली देख पाए कि एक वेरिएबल की वैल्यू, व्हाट इज द वेरिएबल वैल्यू. आई कैन शो इट द सेम थिंग, but I won't be able to show it in C. I can show in Java because there are essential tools available in IDE, right? But you will rewrite the code. I will use the same code. The language is different, but I will use the same code. Let me copy this code. I'm doing this to make you understand. Otherwise, I should not do this. Okay? Don't worry if you have not seen this ID before. It is not meant for you to be shown, right? As of now. Just focus on the code. In fact, it's just at the runtime I'm deciding to go for it. I have not thought that I will be using it, just because I feel that you are still not able to understand, so I'm trying to go for a different approach. Okay. Let me open any project. Don't worry what all these things are. Okay. Okay. Don't worry what I am creating as of now. When I will start telling you understand from this point, only just pay attention from that point. Don't worry what these terms, class and everything means. Okay. I don't know why my this laptop is giving me a difficult time. क्या करें यार? See, forget everything which is above, starting from line number 3. Forget these things. Okay. All you need to understand is this function, linear search, right? You know what a linear search function is. It is the same thing that I have copied from the that page that I was just showing. Now, if I need to call it from the main function, just know it's a main function, just like in C. Forget everything what it has got, right? Forget as of now. What I am doing is I am just populating an array. I am creating an array. Okay? Even don't bother about the way I am creating the array, or rather I will try to create in the way you are used to see it. Okay? The variable name is ARR. Okay, int ARR this 2 comma 4 comma 6. This is what we talked about, right? Just now. Okay. Okay. So I have created an array. This is the sign of the array. This is the name of the variable array. Okay. And 2, 4, 6 are the element. Let me say position in position is equal to 0. That was the starting point, right? Correct. Int key is equal to 6. That is what we decided, right? Int n is equal to what? 3. So I think this is clear, right? I do not need you to understand the language constructs, right? I just need to understand you the syntax of the code, which is very much similar like a C program. Now I'm going to do something which you should not bother. You will just be bothered with the result that we are getting after it. I'm going to run it. Okay? Forget whatever I'm doing. None of your business. This was the code, right? Now I need to call that linear search, right? From the main method. LINER linear SEARCH linear search. Okay? And don't worry about the keyword that I am adding. What should I pass here? ARR as per the C syntax, 0, or rather POS, right? Then key, then n. This is what I need to pass, right? And then as per the base case, I will return the index position. So let me say another variable, index of found position is equal to, ठीक है, this has to be an integer, right? ठीक है, index that will ultimately return where the element is found. In our case, that is 2, right? Correct? Now, the green line, the line in which the green bar is there, that is the line which is currently being executed. Now start from understanding from now on. The line which is highlighted in green, that is the starting entry point, because main is entered first. Main is the method which is entered first in every language. Forget it is Java, it is C. Okay? There also main is the function which is entered first. So main is entered. Array is populated. I am going over or moving over with the next step. Now I will control the steps and I will try to analyze in each steps what is happening. So here the array is formed, right? If array is formed, it has got 3 elements. Element at index position 0 is 2. Element at index position 1 is 4. Element at index position 2 is 6. Array is created with all the 3 index. You can see it visually from your eyes. Now this system is no more a black box for you. It's a white box. You can look into each of the every variable. You can traverse steps on your own, right? Position is not seen over here as of now because position is not created and initialized over here. Let me move a step again. See, position has appeared with 0, the initial value, right? Correct? भाई ध्यान से देखो, steps clear होना चाहिए, ठीक है? Then key is 6. Let me move a step further. This will also be initiated. Key becomes 6. All the variables are being created over here with the live values. And if the values change, that change will be reflected over here. Look at this right side of the window. Okay? This window. Okay? And this is the steps or the code instructions which are being executed at a time. Now, I am moving to the next element. N is equal to 3 is initialized. Now, I have to get inside this linear search method. Okay? I will do something and it will enter into linear search. This is the linear search method, right? See, when it has entered, now it is showing all those values. Array is still containing those 3 elements, 2, 4 and 6 in the same index position 0, 1, 2. With position is equal to 0, with key is equal to search key is equal to 6, with n is equal to 3. This is the first entry of the linear search. Correct? Now, whether this condition becomes true or false, tell me. Here is position, here is n. True or false? False. If this line would have executed, I would have returned from this method immediately. But this is not executed because the condition was false. I moved a step to the base case 2 in line number 12. Array position, what is the position value? 0. Array at position 0, this is that value, 2. Whether this value 2 is equal to the key, which is equal to 6, true or false? False. I will not enter into the statement which says return back with the position value 0, right? This will not be executed. I am going to move further. Now what is happening? It is calling again linear search with the same array, and this time position will become position plus 1, that is 0 plus 1 is equal to 1. Once I enter into it, right? So let me enter into it further. So again, the same function is being entered. It has come back to the first line, right? Right? Now see the position. Position becomes 1. Rest everything is same. Rest everything is same. N is 3. Key search element is 6. Array elements are 2, 4, 6. Still at index 0, 1, 2. Right? Now tell me what is going to be the output of line number 8. Value of position is what? Value of position is what? यहाँ देखो ना भाई 1. Value of n is what? 3. 1 is greater than 3, true or false? False. False means I am not going to return back. I am going to move further, right? So I am going to move further. Now the second base condition is being checked. Array of position. Position is what? 1. Array of 1 means this element, right? Which is 4. Key is what? 6. If 4 double equal to 6, if 4 is equal to 6, true or false? False. I am not going to return position again. I will move further. I am going to break the problem into one more smaller step. With position will become position plus 1, and that will be 2 this time. Earlier it was 1. Now if we enter, it will become 1 plus 1, that is 2. I am calling the same function. Okay? The same function, linear search. Again the control will come to the, I'm sorry, what happened? Okay, no worries. I have done a mistake in the steps. I will just show it again. I will come to that point exactly where we have left. Just a second. Yeah, see, position becomes 2, right? Okay. Now what is the base condition? 1. If position 2 is greater than the value of n is equal to 3, and in fact this would mean that we have traversed all the array elements, which turns false. So we are moving further. Okay. Checking for the next base condition, which is array of position 2. What is the value of array of position 2? 6. Double equals to key. What is the value of key? 6. Are both equal? True. Now this return position should come into effect. And in this case, what will happen? The control will jump from here to the previous call of linear search where the position was 1. You see? The position was 1. Okay? Correct? Okay? Now, at this point where position is 1, this linear search was called from the place where position was 0. Right? I will come again to the same position. And that place is what? From the main method. Right? And when this statement execute, index found position is what? 2. This is where 6 lies. तो आप ऐसे समझ लीजिए कि मैंने what I did is I called the function with position 0. It did not work. It came back. I called it again with position 1. It did not work. It came back. Okay? And then I called with position 2. It worked. And when it came back, I will return in the same reverse order. Like one call, second call, third call, it will come back to the second call, then the first call from the main, which is the zeroth call, right? So I will come back ultimately at the start position where I have started with position is equal to 0. But the return value of the position which has been 2, the return value is being carried as it is. The result is being carried as it is, handing from one hand to the other, right? Right? The only difference is that here in the case, I am giving the task or delegating the task to the same person again and again. He is coming and going, coming and going, coming and going with a shorter problem until he found one of the base cases, right? So I got index position 2. If I want, I can write a statement to print whatever is at index position 2 in this array, which is 246, right? I can do that. Let me just write that statement. Forget how we are doing in Java. Just I am printing that element, element found at index value is equal to, okay. Now I am not going to show you uh, this way, like step by step. I'm just going to run in one go to see the output. Element found at index 2 value is equal to 6. Correct? ठीक है? ठीक है भाई? Same will work in if I put that C code into with a main method implementation into any of the online C compiler or code block, it will work there also. Yeah. Please repeat again. Yeah. It found the base condition. One of the base condition become true. So it will return back to the place where it started for position 1. Then from there it will return back to the place where it started from position 0, which is the main method. And the main method it is printing back. No, no. Recursion is not going back. Recursion means calling the function again and again. Ultimately, it is by natural that it will come back to the place where it is being called from. Okay, so it will come back in the same steps as well, right? Just a second. अरे भाई हाँ बताइए क्लास में है क्या हुआ क्या कह रहे हैं नहीं नहीं अभी तो मैंने देखा भी नहीं है नहीं देखा था भाई मैं क्लास के अंदर okay guys it is not going back because it has something to do over there. Rather, it is just going back to the caller. Yeah. Like for example, if I hand over a task to you, then you will come back to me, right? If you hand over the task to the next person, he will come back to you, right? If we hand over the task to the other person, he will come back to him, and then he will come back to you, and then you will come back to me. Now assume this all these three person are the same function. Okay? Because it is being called recursively. So this is also act the same way, that it will keep on calling itself, and when the thing is done, it will keep on returning back to itself with the return value until it reach to the main method where the call has started for the first time. Okay? It will start unwinding itself. That's the idea. Because there is a return, and the return is always happened to the caller, and the caller was also the same function with a -1 position value, right? So it will come back to the caller, which is called with a lesser position value. Then it will send it back to the caller, which is again the same function which a lesser value. That will come back to the ultimately to the main method, in our case with element 3. So it's a kind of unwinding the call. There was no there in that case in a linear function within the same for loop, the iteration keeps on going, and that's why it was easier to visualize, right? Here I have to use things like, you know, this breakpoints to show you how things are working, to make you understand that. Okay? Come again. In the linear search without recursion, yes. Yes. Index was incrementing on its own. Here also we are incrementing the index position, right? This is the updation in a way, right? That is how we are reducing the search space, right? Okay. Got the idea, guys? There is some meeting. I have to go for some work.